Hi guys, welcome to this page of the notes. And again, what we're doing is we're graphing radical functions or functions that have a radical in them. In this case, it's a square root. And we know in order to do that, the first thing I need to do is figure out what's going to make my radicand negative and exclude those values from my domain so I don't wind up with imaginary numbers. So we're going to start by doing that. And we'll do it right down here. My radicand is just what's underneath of the radical symbol, negative 2x plus 3. So here we go, minus 2x plus 3, and I set that greater than or equal to 0, greater than or equal to 0, because I want this to be positive, right? The radicand needs to be a positive number, so I can take the square root of it. If the radicand were less than 0, it'd be negative, and the square root of a negative number is imaginary, which is no bueno. We can't graph imaginary numbers. So my radicand needs to be bigger than 0. But it can be 0, that's why I have the equal sign, because the square root of 0 is 0, and that's perfectly okay. Let's go ahead and solve this guy. Subtract 3 to the other side. And then to get the x by itself, I need to divide by a negative 2, but please be careful. This is really good review of working with inequalities. Anytime you divide, multiply, or divide a negative number from one side of the inequality to the other, you have to remember to flip that inequality sign. I'm going to be dividing both sides by a negative 2, which means I'm going to need to flip my inequality. So x is actually less than or equal to a negative 3 divided by a negative 2, which means x is less than or equal to 3 halves. Now remember, 3 halves is 1.5. Let me throw this on a number line one more time for you, just because the number line is a great way to visualize what's happening here. I draw my number line, and this tells me that my domain are all numbers less than or equal to 1.5. Well, let's see what that looks like. There's 0, 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. Well, where is 1.5? Well, 1.5 is right there between 1 and 2. And what this tells me is that it's all values less than or equal to 1.5, which means I'm actually going to the right on this number line. So it's 1.5 and everything less than 1.5. It's everybody going in this direction. So what that means is when I set up my XY table and I choose domain values, I'm only going to choose domain values that are down here on my number line. I'm not going to pick numbers up here, which is actually kind of weird. Generally, when you think of picking numbers, you think about picking 2, 3, 4. Like, those are really easy numbers to work with. But my math tells me that those numbers are excluded from my domain because they would give me a negative number, and I don't want to take the square root of a negative number. So we're actually going to be working with numbers all down here. And again, the number line is a great way to visualize what the domain is telling you. Now, we've already found the first number that I'm going to plug into my table. So let's go ahead and plug 3 halves into my table. Let me get it set up. 3 halves is going to be the first number in there. And there we go. We plug 3 halves in for x. Negative 2 times 3 halves. The 2's are going to cancel, leaving me with a negative 3. Negative 3 plus 3 is 0, and the square root of 0 is 0. But then, guys, look, I already knew that. I set it equal to 0, and I solved and got 3 halves. So I knew plugging in 3 halves was going to get me 0. I knew that was going to happen. All right, now we're going to work smarter, not harder. So let's go ahead and set up our side work right over here so that I can get nice, neat integers to graph instead of crazy, irrational decimals. So, got my side work. I have already set the radicand equal to 0. So now let's set the radicand equal to my next perfect square, which is 1, right? That's my next perfect square. And solve. Negative 2x is equal to a minus 2. X is equal to 1. So here's what I know. If I plug in a 1, my radicand is going to come out to be a 1, and the square root of 1 is 1. So the next point in my table is going to be 1, 1. Awesome. That's a nice, neat point. Let's do another one. My next perfect square is 4. So negative 2x plus 3 is equal to 4. Negative 2x is equal to, subtract the 3 to the other side, I get positive 1, which means x is equal to negative 1/2. All right, I don't really like that. That's going to give me a decimal. Not that it's negative 1/2 is that terribly difficult to graph. I know it's not, but I'm going to avoid decimals if I can. So let's try a different one. My next perfect square is going to be a 9. So negative 2x plus 3 is equal to 9. Let's solve that. Negative 2x is equal to, I subtract 3 from the other side. That's going to leave me with a 6. Divide by a negative 2, and I wind up with a minus 3. All right, so that's perfect. I know if I plug in a negative 3, my radicand is going to come out to be a 9, and the square root of 9 is 3. So my next point is negative 3, 3. So we'll plug that into my table. If I plug in a minus 3, my radicand is going to be a positive 9. Then I take the square root of that. My range value is going to be 3. Let's see if we can find one more. Let's see, I did the perfect square of 9. Let's do the perfect square of 16. Negative 2x is equal to a 13. So that's not going to come out to be nice. That's a negative 7.5. Sorry, 7.5. Whoa. 6.5. Which is a decimal. And not that it's terribly difficult to graph, but I ain't got time for that. Negative 2x plus 3 is equal to 25. That's my next perfect square. Negative 2x is equal to 25 minus 3 is 22. Oh, hey, we found one. Negative 11. All right, so that one doesn't quite exactly fit on my coordinate plane, but it's close. So I'm going to go ahead and use it. I know if I plug in a negative 11, my radicand is going to come out to be a 25, and the square root of 25 is 5. So my next point is x equals negative 11. Y, the range value, will be the square root of 25, which is 5. So we'll use negative 11 and 5. All right, let's go ahead and graph those points. I think I got plenty here. And here we go. 3 halves is 1.5 and 0. So 1.5 and 0 is right about there. And again, I don't really like graphing decimals, but I don't have a choice. That's the first value of my domain, so I've got to use it. I've got to know what that starting point is. And then we go from there. 1, 1. Oh, that's easy. Negative 3, 3. And negative 11, 5. Negative 11, 5. Right about there-ish. It's just off my graph a little bit, but it's close enough. I can squeeze it in there. Connect those dots with a smooth curve. Make sure you put an arrow on the end that just keeps going off to infinity. That's my starting point. That guy just keeps going, and you have graphed the function y equals the square root of negative 2x plus 3. Guys, that is great work on this one. I have another example problem for you on the next page of the notes, so head on over, and I'll meet you guys there.